All right, so being able to graph, I put kind of the 5 big ones. You notice I didn't put exponential, and I kind of wrote the 3 main ones. I really want you to know linear, quadratic, and absolute value well. And then square root, cube root, cubic, those are kind of nice to know parent functions, but not the focus. And then exponential, I put it on there, but it's not a focus at all this unit, just recognizing, oh, that's an exponential graph, that's nice. We're going to spend a whole unit on exponential functions, so I'm not looking to assess that right now anyway, so I just left it off the quiz completely. So I hope you know that's a linear function, right? Y-intercept at -3, and it's just a slope of up 1/2 in either direction. So linear functions hopefully should be in your memory bank, and if not, y equals mx plus b, you got to review that. And then this one is just a cubic function that's been shifted up 2. So when the transformation is over here away from the function itself, like this is inside the function, so that's left or right. This is inside the function, left or right. This is outside the function, so that's a down 2. So if it helps, we can kind of go over the parent function. So the parent function of a cubic, 0 cubed is 0. So I'm just going to plot the parent function first. What's 1 cubed? 1 cubed is 1. And then 2 cubed is 8, so that's like way up here. What's -1 cubed? -1 cubed is -1. What's -2 cubed? -8. So the parent function is kind of this S-shaped graph through the origin. So I'm just going to take those points that I can fit on my graph and just shift them all up 2. So the real function is up 2, up 2, up 2. So it kind of looks like that. Just general idea of the shape, that it's kind of that twisty graph, but you can plug in values around the origin, get your parent function, and then just shift it. Same thing for the square root graph. So inside the function or inside the parentheses, it's kind of a weird world. Everything's backwards. So -2 actually shifts you to the right. And the reason for that is if you plug in the number +2, isn't 2 minus 2 0? So 2, 0 is a point on the graph. So it actually shifted it to the right. The parent function square root graph, I can't take the square root of a negative number, so there's no graph over here. I can take the square root of 0, 0. I can take the square root of 1, 1. I can take the square root of 2, but I get like 1.4. Square root of 3 is about 1.7. So my next perfect square is 4. The square root of 4 is 2. So your parent function looks like that. It's like half a parabola. And then this is shifting all those points to the right. So right 2, I'd be here. Right 2, I'd be here. And right 2, I'd be here. Like that. Oh, and I was supposed to state the domain and range for each of these. So all linear functions, unless they're horizontal or vertical lines, are all real numbers for both the domain and range. The arrows are going forever left to right, and they're going forever up and down. So the domain and range would both be all real numbers for part A. Same thing with part B. It's a steeper graph, but it's going to keep spreading out side to side and spreading out up and down. So its domain and range would both be all real numbers. And domain always goes with X, range always goes with Y, alphabetical order, domain then range, X then Y. Square root functions. So I don't have arrows going in both directions anymore, right? My graph on the x-axis starts here, and then it goes forever in this direction. So my domain would be x is greater than or equal to 2. And on the y-axis, if I kind of squish my graph over to the y-axis, I'm starting at 0 on the y-axis and then going up forever. So my range would be y is greater than or equal to 0. How are we doing on domain and range? Does it make sense what domain and range is? Because that's important from Algebra 2. Okay. How did we do on, now that I've showed you those 3 parent functions and shifted them? Feeling a little bit more confident, maybe? Yeah? Okay. So absolute value, the parent function is a V-shaped graph at the origin that's going up with a slope of 1 and -1. Because absolute value is just the distance from 0. So the absolute value of 0 is 0. Absolute value of both 1 and -1 is 1. Absolute value of 2 and -2 is 2. So this has gone now left 3 and down 2. So what I would do is I would just go left 3, down 2, and then just regraph those points because I know it's an easy slope of just up 1 over 1. And then if you had to like, if there was a stretch out here like twice as steep, it would just change your slope of those lines to 2, up 2 over 1. If there was a half in front, it would change your slope this way. Then it would be up 1 over 2. So it'd be less steep if it was half. It just changes the slope of the line to a half, or to 2, or to 4. And then if there was a negative sign, that's what would flip it over upside down if there's a negative out here. Let's see, my domain would be all real numbers because it's going forever in this direction, but see how the bottom of the graph is here and it never goes below that? So your y values always stay above. Y is greater than or equal to -2. We're staying above -2. And then the last one, this is a cube root function. It's actually this function up here turned sideways. So a cube root asks you what times what would be that number. So the cube root of 0, I'm going to do the parent function first. Cube root of 0 is 0. Cube root of 1 is 1. The next perfect cube is 8. The cube root of 8 is 2. So it's basically this set of points just turned sideways. Cube root of -1 is -1. Cube root of -8 is -2. So it's this sideways curve. So the only thing that it does when the x values are made negative, it takes all these x values and puts them over here, takes all these x values and puts them over here. So 0, 0 stays in the same place, but this point now goes over here. It kind of flips over the, what's that? The y-axis, right? So a negative x, it flips over the y-axis because all the x values you just made negative. And if there's a negative sign like in front of the function, it makes the function negative. So it flips it over the x-axis. And domain and range would still be all real numbers. And on your quiz, I don't think did I ask you that many questions? I asked you a couple like transformation questions, like describe the transformation up, down, left, right. There wasn't a whole lot of graphing by hand. Identify the domain and range. So I think these are actually a little bit harder than what I asked you to do on the quiz, but still need to know those transformation rules. So giving information and having to write the equation. So let's see, it's an absolute value function. Did you have time to try these? Okay. Absolute value function flipped over the x-axis. So that's upside down and shifted left 4. So y equals negative absolute value of x plus 4. There's my upside down and there's my left 4. Square root function that's been shifted up 8 would be a plus 8 outside the function to go up 8. And a quadratic function shifted right 2 and stretched by a factor of 4. Let's see, right 2, and it's quadratic. So there's stretching by a factor of 4, there's right 2, and then it's vertex form. So does that kind of make sense? I think these are harder. You have to come up with the equation yourself. So there's a couple where I gave you a picture of a graph and you're writing the equation based on the graph. So kind of the same thing. Just like write something down and then be like, oh, this has to be a plus, or oh, I need a 4 right here. You can do drafts of your equation. Okay, I know it's a plus 8. Now what do I have to do here? Does that make sense? And use the other equations or the other graphs on the quiz to then help you answer, when you can't think of what to write. Oh, yeah, Flipped over the x-axis, it's a negative leading coefficient in front of the function, right? Flipped over the y-axis would be just the x value being made negative inside the function. So if I had made this one negative inside the function, like negative absolute value of x, then it would flip over the y-axis. But absolute value flips its own leg on top of itself. So this, you don't actually see a transformation because it's symmetrical already. So you only see a transformation kind of flipping that one upside down. Yeah. Yeah, I usually don't give right or left transformations with flips over the axis, but let's answer that question. So for example, if you had the absolute value of, see, I think if we type it two different ways, it's going to look different. So if I have the flip there, that's the negative sign, and then parentheses like x plus 2, to me, that's flipping it and that's shifting it left too, right? So it did just leave it there. So basically it moved the axis over to here and then it still flipped it symmetrically. So see how it didn't end up moving it over here? Like it doesn't go like that. So it moves the actual y-axis left too, and then it's just revolving around that axis that's been moved. I usually don't do left or right shifts with that kind of flip though for that reason. It's kind of confusing on how the equation would work. I try to do like single transformations or like a stretch with a transformation, but that's a really good question. I think that's a confusing one. I think I'd let you use a calculator if I was going to do that type. All right, so this to me is still vertex form because it's just that up or down. This is standard form and this is intercept form. You could put them all into standard form and do negative b over 2a. The parent graph of a quadratic, right, would be 0, 0, 1, 1, and 2, 4. So I'm just putting the parent graph there as a reference. That's the parabola. So this is shifting everything up 3 and then flipping it upside down over the axis. So it goes up here at 3 and then it goes over 1, down 1, and over 2, down 1, 2, 3, 4. Now I have too many dots on my graph, but so I guess that's kind of the same thing, Krishna, right? We shifted it up, so now we've moved the x-axis kind of up here, and we're flipping it upside down from that point. Okay, so then this one is negative b over 2a is an x value of negative 1, and then you've got 3 minus 6 minus 2 is negative 5. Is that what you got as your vertex? Negative 1, negative 5. And when you stretch a quadratic, so if the original points were 0, 0, 1, 1, and 2, 4, you are stretching all of the y values times 3. So now you're going to have 0, 0, 1, comma 3, and 2, comma 12. So it's just the y values that get multiplied by 3. So when I'm doing this graph, I'm going to go over 1 and up 1, 2, 3 times as tall. And then up 12 won't really fit. So just kind of do a steep parabola curve because then it would go over 2 and up 12. So it would be just above the graph a little bit, like way up here. Just don't make it look like an absolute value graph because a parabola is a curve. And this one is called intercept form because it's factored. And so you can plot your two x-intercepts. This has an x-intercept at 1 and at negative 1. So you know that the vertex is somewhere on the 0 for x. You just don't know what y is. So you're going to take 0 and plug it into the function. So you'd get 0 plus 1 is 1, and 0 minus 1 is negative 1. So 1 times negative 1 is negative 1. So this must have a vertex at negative 1, which makes sense because my a value is 1. So it's just the normal parabola. Over 1, up 1, over 2, up 1, 2, 3, 4. Like that. But if you wanted to do FOIL, you could FOIL this out and you'd get the function, what, x squared minus 1, right? Because the outer plus the inner add up to 0. X squared minus 1 has an intercept down here at negative 1, and that would be that same graph. So I think quadratics might be hard just because some of you haven't done it in a long time. Do the best you can on that question, but there will be some quadratics on your test next week. And then what about factoring? So I'm only going to assess you on like the 3 strategies that are kind of easiest, which is like greatest, oh, I listed them, greatest common factor, difference of squares, and trinomials. So I'm not going to include on the quiz Those cubes, unless it's a bonus, the quartic functions or the grouping. So these are just on your quiz. The rest would be like a bonus, but this is difference of squares. So 3x plus 5, 3x minus 5 equals 0. When you then have to solve these, it's the zero product property, and you can set each part equal to 0. So if 3x plus 5 equals 0, you're going to subtract 5 to the other side and divide by 3. So negative 5/3 or positive 5/3 are your x-intercepts, right? Huh? So yeah, if I say to factor, then you're going to leave it at this step. And if I say to solve, you're going to go all the way to this step. Yeah. This one you would have to use the box method for. Yep. Yep. I'm trying to think, how would you have learned factoring this? Did you learn any other strategies? Did you learn grouping maybe? Oh, you did learn box method? Okay. I was going to say there's a bunch of different ways. So depending on where you take algebra, there's a bunch of different factoring strategies. This one is just the diamond method, right? There's 3 terms. We're looking for the factors of 4 that add up to -4. So x minus 2 times x minus 2. So x can only be 2. It only has one x-intercept. It must bounce off the axis, right? Multiplicity of 2. I didn't put multiplicity on the quiz, but good to start recognizing that, that would bounce off. So the box method, you can't factor out a greatest common factor, so you need to do your box. So can you see this? To set up your box, it would be you put your 4x squared here and your -15 here. So we need to strategically split up this 4x into these other boxes because this is going to represent our original quadratic. So you do a modified diamond in that you take this 4 times this -15, and that becomes the top of your diamond, -60. And then this 4 is still the bottom of your diamond. So you're looking for the factors of -60 that add up to 4. Did anyone do this one successfully? What'd you get, Lily? Or what'd you get as your factors of -60? Right, so -6 times 10 is -60 and adds to 4. So these are how you're going to split up your 4x into these boxes. -6x, positive 10x. It doesn't matter which box you put those in, just make sure you put the x at the end of them. So now I need to come up with what times what is going to give me the product of all those things. So I think about 4x squared first. Do I want to do 4x times x, or do I want to do 2x times 2x? If you tried to do 4x, you would have a problem because you have a 10 here and a 6 here. You're going to want to use 2x times 2x to get 4x squared because you're thinking down the road, I have to be able to get to 10. So 2x is the length, so 5 has to be the width because 2x times 5 is 10x. So this is a 5. And then 2x times -3 is what gets you the -6x. And then double check that this last product makes sense. 5 times -3 is -15. So your factors are 2x minus 3, 2x plus 5. So your solutions would be 3/2 and -5/2. And so you don't have to walk as far next time, Krishna. There's another box by that pink shelf. Save your steps. Does that make sense? How to solve for x at the end? Because these can be challenging factors to solve for x. So if I'm doing it too quickly, I can write it out and break the steps down for you. You set the factor equal to 0 and solve for x. So if I'm going to solve for x, I have to add 3 to the other side and then divide by 2. That's where 3/2 comes from. If you plug in 0 for x, you would just get -3. So you're setting each factor equal to 0. Up here, I could do it in my head because I know that 2 minus 2 is 0. So I didn't have to do a lot of work. So I think, for some of you, if you haven't taken trig or algebra 2 recently, factoring is challenging, but we've got to push the factoring so that you can be successful with rational functions. All right, so I can name polynomials. So this is what, a cubic. Maybe you thought to write binomial. It's a cubic binomial. Standard form x cubed minus 2x. So the degree is 3 and the leading coefficient was 1. And I didn't ask you end behavior or multiplicity. Hello. Ava, right? Ava, welcome. We did some quiz review. That's the page we're going over right now. And so the last one is just a linear function, right? So this one's a linear, I guess I made it a binomial again. It's already in standard form, and the degree is just 1 this time, and the leading coefficient -5. So maybe number 5 is actually easier than some of the other things that you had to review. Yeah. Did you have a question? Okay. It means 2 terms. So if I had just written y equals -5x, that's considered a monomial because there's just 1 term. Or x squared plus 2x plus 9 is a trinomial because there's 3 terms. X cubed plus 2x squared plus x plus 1, that's just called a polynomial because there's more than 3 terms. So there's no special name for that. So you would call that a cubic polynomial. I don't even know if I had you name it. Let me see on the quiz. State the degree leading coefficient or explain why it's not a polynomial. What are the things that would not qualify as a polynomial? Krishna? Sure, that's an example. So like x to the 1/2 would not be a polynomial, right? Give me something else that would not be a polynomial. Something without a real coefficient. So like the square root of a negative number, or like 5i times x squared, right? We can't have imaginary numbers in there. And then there's one more or 2 more examples of things that I don't really want to be polynomials. Not just fractional exponents, but yeah, we can't have negative exponents, which rules out any x's in the denominator. We can't have square roots. We can't have absolute values, right? Those aren't polynomials because they're not smooth curves. Like this has that jagged edge. Yeah. Okay, so I'm going to stop.